Hello and welcome back to What Exactly. In this video, we are going to build a language translator using transformers, but this time from scratch. Okay, let me show you the results before getting started. See, this was my language translation task. I converted a French sentence into an English sentence. See, this is the result. This was my input French sentence, and this was my predicted sentence. So my predicted sentence was, can you get me a good dictionary? And the actual sentence was, can you recommend a good dictionary? It was almost perfect, but if I increase the training time, it will give me better results. Okay, see, did you get the paper? Did you get the loan? Go to the room, go to your room now, go to your room now. So it's almost better. So if you train for a longer time, you'll be getting good results. Now let's get started how to train this. Okay, initially I'm having a data set which I'm importing all the modules. I'm importing pandas, numpy, tensorflow, and all this stuff. Next, I'm reading the dataset. See, here I have used Kaggle, which is an online dataset platform. You can also use Google Colab. I have directly imported this dataset. I'll be providing the dataset to you. So it is in this folder, which is English to French.csv. So let me run this and let me show you the dataset initially. So this was my dataset. And if I run this, I got hi, and these are the English words and these are the French words. Let me clear the output. And see, I'm pre-processing the data. I'm adding initially start of sentence token and end of sentence token. This enables a transformer to understand that whenever we encounter an end of sentence token, we must break. So that's why I'm adding a start of sentence and end of sentence token to each and every French word as well as English word. Okay. See, this thing you can do by just writing SOS plus df of French word plus EOS. The same thing you can do, and you must write reset index is equals to true. Okay, and if I run this, I'll be getting start of sentence followed by English sentence, then end of sentence. And I'm also sampling the data. See, initially our data frame was just hi, hello, and it wasn't. Let me run this again. So initially you have one word sentences, then you have bigger word sentences. But in order to train our data, we need to shuffle the data. So that's why I'm sampling it. And this is the argument which I'm sending to the sampling. Okay, let me look over the data. This is my data. Tom has never been overweight. So this is the French converted sentence. We only want you, and this is the French converted sentence. So next thing, as I already told you, system do not understand strings, so we need to convert into an embedding, right? So if you are you need to if you are familiar with the tokenizer, you can understand this. See, I have imported tokenizer from keras.preprocessing.txt. So what does this tokenizer do? Let me show you in the notebook. So initially, if my string is hi, suppose this is my data, train data, hi, hello, how are you? So what does this tokenizer do is, it will take all the words in the form of dictionary. Hi, it will assign hello, it will assign 2, how, it will assign 3, are, it will assign 4, and you, it will assign 5. But this time it's not similar to dictionary, but somewhat similar to dictionary. Like, it does not directly take high and it will allocate 1. So what it does is, it will take the most repeating characters. Like, suppose our sentence has 10 highs. So high will be given the index 0. And suppose if it has 10 hellos, till hello will be given index 1. The same thing follows. So the count of of a word, if it is high, it will give the lower index. This is about tokenizer. So what we are doing, we are initializing the tokenizer class. So tokenizer followed by circular brackets and fit on text. What is fit on text do? So simply here what we are doing, we are letting our tokenizer to fit on these texts. Like, we need to create a dictionary of hi, hello, how are you, right? So that's what we are doing here. We are fitting it on text. And what we are doing, we are returning the sequence. Let me show you. Let me create a tokenizer. Tokenizer is equals to tokenizer, and let me fit on text tokenizer dot fit on texts. Let me take my text to be hi, hello. And if I run this, let me show you what happens in the tokenizer dot word index. So it is actually taking it in the character level form. So let me give it as a list of words. Hi, hello, sorry, hi. See now hi is given higher priority. So this is how we convert using a tokenizer. And if you want to convert a sequence into text, so you can do it simply by writing sequences to text. If you want to convert a text into sequence, you can just use the command text to sequences. So this will convert. So let me show you tokenizer dot text to sequences of, let me take the text hi, hello. So what it does is it will simply put index of hi, which is 1, and hello. So the key is 2. It will put the 2 here. So it will convert this and it will return. Okay. So we are returning text to sequences as well as the tokenizer. Let me run this code and pad. So why we need padding? As I already told you, we are processing the data parallelly and we are following a CNN style of network. So what we want, we have a maximum length here. But simply if we pad the numbers, like if you have hi, hello, and some other words may have hi, hello, how are you. So some words may have two words, some words some sentences may have three words, some sentences may have five words. So what we are doing is we are taking the maximum length and we are padding zeros. Suppose you have high, so suppose our maximum length is 14. So what we do is high has 1 and we follow all the other things to be 0. So we are padding high to the length 14. So 1 followed by 13 zeros. So that's what we are doing in padding. So here, for the sake of simplicity, I have taken 14, but in practical thing, you can take 57 or 86 or some other thing, or the maximum length of the sentence. In this data set, the maximum length of the sentence is 57, but when I change the length to 57, what is happening is my notebook is collapsing because I'm not having sufficient resources. So that's why I've taken 14. You can also play around with this thing. Okay, so what I'm taking a sequence X and I'm taking maximum length 14 and I'm padding the sentences and the padding must be post. So what is post? We will be having two types of padding. One is pre-padding and one is post padding. So we are padding after the data here. See here, we are padding after the data. So that's why we are taking padding to be post. So this is about padding. Next, cleaning the data. Just cleaning the data. Why we are cleaning the data? Because we will be having a data set from different resources. So one may represent, we may have some garbage values. So what we are doing is we are replacing everything, every small alphabet of higher case to lower case, and we are removing all the other stuff. Okay, this is about cleaning the data. For more details, you can also Google it. Let me just clean the data. And I'm pre-processing the data. What I'm doing in pre-processing, first I'll be tokenizing the data and I'll be padding the data. That's what I have done here. See, I'm tokenizing the data X and I'm see X and Y are like your input and output sentence. Suppose I want to convert from English to French. I can give X as English and Y as French and vice versa. So I'm tokenizing the data. After tokenizing the data, I'm padding the data and I'm returning all this stuff like preprocess X, preprocess Y. So the thing after tokenizing and padding, and Y I'm tokenizing and padding, and I'm also sending the tokenizer X tokenizer and Y tokenizer because we want it during testing. Let me run this and see I'm storing the data. Okay, let me take, okay, see here it takes some time because, okay, it takes some time because the data set is very huge. So let me run this command. So initially what we are doing is we have written the code for this and we are sending English sentence and French sentence. So we are sending English and French sentence. So finally what we are getting, we are get let me show you in English sentence initially eng of 0. See, we got I think we have something in common. But when I pre-process the data, I'm running this English sentences of 0. See, I'll get sequences and it is also padded. Initially, if you assume this 1, 2, 3, 4, 5, 6, 7 words, we have 7 words. But when we pad it, we have 14 words. So we have done pre-processing step. And our training set has 1,75,621 examples. See here we have pre-processed the data. We have English as well as French of same length 14 and 14. It's a hyperparameter again, you can change it. You can also based on your compute power you can change it. You can also put 57 or the maximum length of this dataset. In this dataset the maximum length is 57 here and I guess 34 here. Okay, let me show you. Okay, and the other thing is we need to store the maximum length of the sentence. So for English sentence the maximum length is the shape of first one. So this one 14. So I can access it by just writing dot shape followed by square brackets and I put 1. I'm accessing the first element. Okay, the same thing. And English vocab size. What is English vocab size? See, we are having English tokenizer, right? So if I write English tokenizer dot word index. So what it will give? It will give me all the words in this tokenizer or in this dictionary. Okay, so I want to get the maximum length of this dictionary because let me show you. If I write just length of this, I'll get the maximum length of the dictionary. So it means we have 14,533 different words in our English dictionary or in our English tokenizer. You can also play around with this. You can just write French here, and if we run here, we'll get 30,662. Okay, so that's what we have done here. Let me just print this. So we have maximum sequence length for English is 14 and for French is 14, and we'll be having English vocabulary size to be 14,533 different words and French vocabulary size to be 30,662. So whenever you are converting a sentence into a sequence, this will be the maximum word. Like when we are representing here, so these numbers will be having a maximum value of 14,533 for English and 30,662 for French. So this is about the pre-processing for language translator using transformers. Okay, now let us understand positional encoding. So what is positional encoding? As I already told you, let me again show you. Suppose I have a sequence like 12, 14, 18, 22. These are actually sentences like he is a student, as I already told in the previous example. So our model need to have a proper understanding and it should also have the understanding of the surrounding words. Because suppose if we take an example, I have a word Reserve Bank and Bank of River. See, bank in these two words have the same sequence. Like if you are converting it to sequence, suppose this has a number 421 and 421. So when you are representing this number, these two are having the same number. So if I write it differently, if I have Bank of River Reserve, suppose I give you a meaningless sentence like this. See, if we are giving the model parallelly, this sequence and this sequence are same. But if you see here, the context is different here and here. So the word bank is having different meaning here and the word bank is having different meaning here. So we need to include the position and we need to also include the surrounding words context. So first we are dealing with position. So how we can give the positions, as I already told you in the previous video, we are adding what is called positional encoding. So here what we are doing, we are creating a class called positional encoding. And in TensorFlow, if you want to use any class as a layer of TensorFlow, you need to inherit the class tensorflow.keras.layers.layer. So whenever you are implementing this and when you are inheriting this, you can use it as a keras layer. The same thing if you are using dense or max pooling. So these are actually the objects belonging to keras layer. So if you want to use this positional encoding same as those, you need to inherit keras.layers. Okay, I have created the class. Let me initialize the arguments. So what are all the arguments which we want? So initially we are doing self.pose is equals to np.range of maximum length sentence, and we are reshaping it, and we have self.I. So if you go on to the formula, we have position by 10,000 power 2I by d. So this position is a position of the sequence. So if you are having the maximum length to be 4, so our position will be 0, 1, 2, 3 and 4 are the positions. So position will be 0, 1, 2, 3 and 4. So initially here we are just giving the maximum sentence length, and we are creating 0 to 4. So that we can create using np.arrange of maximum sequence length. So let me show you this with the example here. So if I write np.range of 10, this will produce me all the numbers from 0 to 9. Okay, and if I reshape it, the alternative for this reshape is you can also write np.new axis, but here I'm just showing you with reshape. So I'm getting it vertically, sorry. So 0, 1, 2, not vertically exactly. We are creating a two-dimensional array, but for your understanding, I'm saying you, we are getting it vertically, okay? Next, we are creating I vector. See, as I already told you, we are not just representing the number, like we are not representing 12 just as 12. We are creating a embedding vector, and we are letting our model to understand the proper understanding of this word. Like if you are writing bank, so if you represent using numbers, suppose it is 721, this is not enough for our model to understand. So what we are doing, we are creating an array. So this 721 will be multiplied with certain weights, and we get an embedding vector. So the dimension of this embedding vector is, let us assume embedding size is the dimension of this embedding vector. So embedding size is the dimension of the embedding vector. See, we are adding positional encoding for this, so it should be of size embedding size. So that's why we are creating a positional encoding of that size. So why we are taking embedding size by 2, because we are adding sine as well as cosine. So for sine we are adding at even positions, so that's why we have taken half of this, and we are adding at even positions and odd positions, and finally we are typecasting it to float data type, and we will get positional encodings. Let me show you with the example. So let me create an instance of positional encoding. Let me create an instance of positional encoding by using it as a layer. So initially positional encoding will take maximum sequence length embedding size. So let my maximum sequence length to be 5, and my position okay, okay, my embedding size to be 10. Okay, let me run this, and I'm calling on some input, like let my input be an array of numbers np.array 723 7, sorry, let us take 8, 9 and 6 for the sake of simplicity. Been encountered. Okay, this let me take an array this way, np.arr np dot, let me take just once, okay, of size 1 comma 5 comma 10. Let me close this. See, okay, we are taking np, see, this is an array, so what we are doing is we are just testing our positional encodings. So we are sending an input array. So this is our array dot np dot ones of 1 comma 5 comma 10. So if you are adding positional and, okay, I should also add another bracket. See, this is my initial input 1 1 1 1 1. So if we are adding positional encodings, our input has changed to this value. So it is 1 2 1 2 1 and 2 1 2 1 2 1 and 1.84 1.54 1.57 1.98 and so on. So this way we are doing positional encoding.